Now, when we create a multiple instance of a class, each instance will get a unique memory address where memory address. So here we have T1 instance of a class temp. Let us add one more instance T2 of again a class temp. Now, if we try to print T1 and T2, you will actually notice each of this have an independent memory location. So let us just go ahead and print T1 and T2. And now if you observe, so you get an address 433E0 for T1 and 91880 for an T2. So each instance have a unique memory location where a data related to a class will be stored. So each of a class have its own memory location for storing a data. Now we proceed and add a data members to our class. So let us assume we have a module for which we are building a class-based verification environment, and this consists of an input A and B of size 4-bit. For this, we want to add an data member in a class. The primary objective for this will be a generator will be generating a random stimuli for A and B. We'll also be having a data member for an output port, which will be storing the response. Our target here is class should have an independent data member for all the inputs and output ports present in our module. So here both of these are of size 4-bit. So we proceed like this. Now we remove pass and we proceed like this. A equals to 0. So as soon as we add a variable A inside the class, this will be considered as an integer. And then CocoaDB will automatically handle a conversion of 32-bit to 4-bit. This could be done by restricting the random value to be between 0 to 50. We won't be worrying much about sizes yet till we have a real test bench for which we are building class-based verification environment. So let it just remove an ambiguity by adding this to be of size 32-bit. So now we have an integer of size 32-bit and our module input port A also via the size of 32-bit. Likewise, we add B and we initialize this to a 0. So that way, now we have an independent data member in the class for all the input ports which are present in the DUT. So this way, class allow us to form a structure that will hold the data member for all the input and output port which are present in our DUT. Instead of 0, let us go ahead and add some random value. So 10, and for B, we'll use 20. Now we have already created an instance of this class, that is T1 and T2. To access data members of a class, the process is very simple. We need to use dot operator. So we proceed like this. Again, we use a print method to access data member A of instance T1. The process will be something like this. We start with an instance name which is T1, and now you could see it have two data members A and B. To access A, we'll just add A. With this, if we try to execute the code, you could see we get the value as 10. So this is how we access the value of a data member. Likewise, if we add a B and try to execute the code, we will get the value as 20. To update the value of a data member, again, process remains same. We use a dot operator. So T1 dot B will be updating it to a value of 45. And now if we try to again print the value after an update, so you could see value prior to update is 20 and value post update is 45. So this is how we add the data member in the class for input and output port present in the module. And then utilizing a dot operator, we could either read the value of the data member or update the value of data member.